Okay, so I'm going to do the notes for 7-6. This is called the fence problems. So let's look at the first one. It says a homeowner has just enough money to purchase 200 feet of fencing for his backyard. He wants to use this 200 feet to enclose the greatest possible area. So number one, draw a picture of the enclosure and label the dimensions. If you let the shorter side equal the width, which is x. So your shorter side you know is going to be x. Okay, it tells you that in the problem. And you know you have 200 feet. Okay. So your P, which is your perimeter, you have is equal to 200. Okay. Now the equation for perimeter is 2L plus 2W. 2 times the length plus 2 times the width. Okay. So if you know P is 200, then you have 2L plus 2W. Okay. You're going to solve for L. Oh, yeah. And this becomes 2x because your width right here is x. So it's 2x. Okay, we're solving for L. I'm going to write it out here. So now you're going to subtract your 2x from both sides. And you're going to get 200 minus 2x equals 2L. Now you're going to divide both sides by 2. So those cancel, and you get L is equal to 100 minus x. So that's what L is equal to. That's your length. So that length right here is 100 minus x. And this is the same length because it's a rectangle. 100 minus x. Okay. Express the area of the enclosure as a function of the width. So here your area equals length times width. So L times W. Okay. So if you're going to have your length, which is 100 minus x, times your width, which is x. That's your equation. Okay? So now if you type that in, your y equals, hold on. So let's see, we're going to have parentheses 100 minus x in parentheses times x. Okay, so your calculator is going to be zoomed out, right? You're going to be in a standard mode originally. And you can't see anything in standard mode because this is a very big graph. All right, so now this next part, it's asking you to graph this area. So that's why I just put this in y equals. But what I'm saying is when you go to graph it, you're not going to be able to see it in the standard window. So when it says sketch a picture of the function in an appropriate viewing window, you're going to have to modify the window to be able to see it. So you're going to come back over to your calculator, you're going to hit window, okay? And I'm going to put 0 as my min, and I'm going to put my max to be 100, and that's because it's half of my perimeter. So my perimeter was 100 minus x, right? Then I'm going to put my x scale is going to be 20. My y min is going to be 0. My y max is going to be 3,000. And my y scale is going to be 1,000. Okay, so that's what I put in. So your x is going from 0 to 100, and your scale is going to be by 20s. Your y is going from 0 to 3,000, and your scale is going to be by thousands. Okay, so now I'm going to hit graph. And now you can see it, right? A while ago it had a bunch of negatives and a bunch of stuff we don't need. Negative values don't apply for this, for most application problems, right? So now I'm going to plot that. So you can tell this is counting by 20s, so 20, 40, 60, 80, 100. So it's going from 0 to 100. It's going on your x-axis. And in your y-axis, this is going up by thousands. So this is 3,000. So this looks like to be about halfway, which would be about 2,500. Okay, so I'm going to plot that. I'm going to draw my lines. 1, 2, 3, 4, 5. So this is 100. And now this is 1,000. This is 2,000. This is 3,000. Okay, so now we said it's about 2,500, so which would be about right here. And it's going up, and it's peaking in the middle, and then it's coming back down to 100. Okay? So I'm just plotting it the best I can, okay? All right, so now the next one says find the maximum area of the enclosure. So this is the area. This is the graph of the area. Okay, so if we want to find the maximum, you're going to use the maximum on your window. You're going to go to second, trace, you're going to go to maximum, and hit enter. And now you're going to go to the left side of it, and you're going to go to the right side of it. And then enter through the guess. And you're going to get 49.99999, and your y is equal to 2,500. So this rounds to 50, and your y is 2,500. So your peak point right here is going to be 50 and 2,500. That's your maximum point. Okay? So the maximum area of the enclosure is your y value. So it's 2,500 feet squared. Okay? What are the dimensions that will give you the area? All right? So here in the maximum, we know this is W. Okay, this is our width. So we know W is equal to 50. And up here in number 1, we said what? 100 minus X, which was your W, equals L. So you know that L is going to equal 100 minus your W, which is 50. So your L is equal to 50. So when it says what are the dimensions that will give you that area of 2,500 feet, it becomes 50 by 50. So 50 feet by 50 feet. That's the dimensions. Okay. Now let's go ahead and fill this scale in so you have it to look back at. This is how we scaled this one. On the different problems, you're just going to have to play with your scale until you can get the best picture. Now the reason why we chose 100 was because our original perimeter was 200. So our X maximum, we chose about a half of it. Okay. And then on your Y max, in the end, you're just gonna have to play with them to figure it out. Okay, so let's look at the next one. Draw a picture. The homeowner could enclose more area if he used the back of his house as one side of the enclosure. So draw the picture of the enclosure and the dimensions. So here you're going to have X, and you're going to have X, that's your width, right? And we knew 200 equals 2W plus 1L, okay? Because normally it's 2 times the width plus 2 times the length. That's what we used last time. But now we only have one length, because this length is already there. This is your house, right here. Okay? So we only need this one side, so therefore now it's just 1L instead of 2L. So now you're going to have 200 equals 2X plus L. We're replacing W with X. So now we're still solving for L, so you're going to subtract your 2X, and you're going to get 200 minus 2X equals L. So now you know this side is 200 minus 2X. Okay. So now your area is going to be this side times this side. So now it's going to be 200 minus 2X times X. So now you're going to need to adjust your screen, and you're going to need to type your equation in. So you're going to go to y equals, and you're going to type in this equation that we just got right here for your area. So parentheses, 200 minus 2X in parentheses times X. All right, so I still have my scale on here from before, and you can tell that the 100 worked because look, it's going up and down right here, but it needs to go higher. So my Y max needs to go up. So I'm going to go to my window here, and where it says Y max, I'm going to change that, and I'm going to double it. I put 6,000 instead of 3,000. So now we can see the whole thing. Okay, so let's plug that window in here. So we had 0, we had 100, we had 20, that stayed the same. We had 0, but we changed this one and we went up to 6,000. Okay, so now we're going to have our points over here. 1, 2, 3, 4, 5. So this is 100. And now we're going to go by thousands. So 1,000, 2,000, 3,000, 4,000, 5,000, 6,000. Okay, and it looks like our point is going up to 5,000, and it's at the middle, so it's going to be about right here. Is going to be about my maximum point. We're going to find the maximum in just a second. Oops, that's not kind of getting wonky there. Okay. Oh yeah, because I keep drawing my center off. My center will be like right here. So then it would come up like this. Okay. What's the maximum amount of the area of this enclosure? The maximum is going to be your maximum point up here. So to find it on your calculator, you're going to go to second, trace. You're going to go down to maximum. You're going to go to the left of it and hit enter. You're going to go to the right of it, hit enter. And you're going to get 50 and 5,000. So now your point right here is going to be 50 for your x and 5,000 for your y. So what is the maximum amount of area? Your area is your y, remember, right here, a of x, which was area, like y equals. So it's 5,000 feet squared. What would dimensions would give you that? So we still know that our x, our width, right, is this value right here in your equation. So your x is 50, so width is equal to 50. So now we have L is equal to 200 minus 2 times W, right? That's what we said right up here. 200 minus 2x equals L. And you have x is 50. So now we're going to plug that in. L is equal to 200 minus 2 times 50. So then you would get 200 minus 100, which would equal 100 feet. So your dimensions that you would need is going to be your width times your height. So it's 50 feet by 100 feet. That would be your answer. All right, so those are the two, basically the same example, they just changed a part of it for you. Now you can start your assignment. Okay.